What are the first? What are the properties of magnetic field? What we have learned? It has two poles, right? One north pole and one south pole. Ah, it has two poles. One north pole and south pole. Huh. Then like pole, whether they repel each other or attract each other, they repel each other. Like poles repel each other, and unlike poles attract each other. Attract each other. Then what is field lines? The magnetic field lines. The magnetic field lines are imaginary lines. Are imaginary lines drawn to indicate the magnetic field. To indicate the magnetic field. Magnetic field around a magnet. Around a magnet. Okay. So magnetic field lines, they are the imaginary lines drawn to indicate the magnetic field lines around the magnet. So Naina, can you see the screen?
Yes, ma'am.
Okay. So magnetic field lines are imaginary lines drawn to indicate the magnetic field around the magnet. Right. The magnetic field lines, properties of magnetic field lines. Properties of magnetic field lines. So how it will be there? Any bar magnet, if you consider this is a north pole and this is the south pole. So the magnetic field lines originates from the north pole and it terminates at the south pole, ends at the south pole. Okay. So inside it will be from south to north. Inside it will be from south to north. So it starts from the north pole, it ends at the south pole here. Okay. It likes this, it ends at here. Okay. So magnetic field lines are the imaginary lines drawn across the magnet to indicate the magnetic field. So magnetic field we cannot see, right? So that to indicate that we draw imaginary lines, that we call it as the magnetic field lines. So what are its properties? They start or originate at the north pole and they terminate or ends at the south pole. And inside a magnet, the magnetic field lines are from south to north. From south to north, inside the magnet, not outside the magnet. Okay. So it starts from north pole, it ends at the south pole. Inside the magnet, it moves from south to north. Okay, not outside the magnet. Clear now? So if it is going like this, that means what? It forms a closed loop or closed path. Magnetic field lines, they form a closed loop or closed path. Okay. And we observe that if the field lines are more, that means that field lines are more. That means the magnetic field is stronger. If the field lines are less there, so that means the field is less. Okay. So we observe that at the poles, at the pole, the magnetic field lines are more than at the center. That means the pole, the magnetic field is stronger at the poles than at the center. It is stronger at the poles than at the center. Okay. So inside the magnet, it is moving from south to north. So this forms a closed loop or closed path. And here we observe that magnetic field lines do not intersect each other. That means in a magnetic field lines, they do not see it is. It will not intersect like this. It will not intersect like this. Any two magnetic field lines never intersect. Okay, this will not happen. It will never intersect each other. So, what is the reason? If it intersect at some point, then one magnetic field will have two directions. So, this is not possible. Okay, so two magnetic field lines do not intersect each other. What is the reason? If the magnetic field lines intersect at any point, then they will have the two directions for that. That is, they both see when it intersect, what does it mean? They both combine, it can go in both the directions here. So that is not possible. Any magnetic field line will have only one direction at any given point of time, that is from north to south. So never two magnetic field lines intersect. So these are the properties of magnetic field lines. Again, I repeat, what are the properties of magnetic field lines? First thing, what is magnetic field lines? They are the imaginary lines. Magnetic field lines are the imaginary lines that can be drawn around a magnetic field. So that will indicate the magnetic field. Okay, so magnetic field lines originates at the north and it ends at the south. Inside the magnet, it moves from south to north. Inside the magnet, it moves from south to north. Okay, so what does it mean? It forms a closed loop or closed path. Closed loop or closed path. Okay, so any two magnetic lines do not intersect. Any two magnetic lines do not intersect. That means if it intersect, what happens? It will have two direction at any given point of time. So that will not happen. That is not happens. So any magnetic field line will have only one direction. So they never intersect each other. So whenever you are drawing the diagram also, you should draw such a way that they don't intersect. They will ask diagrams also you should write in this. So at that time you should not intersect each other. They will not be marked. Next one, magnetic field. Magnetic field due to a current carrying conductor. Actually, what they've given in this chapter is very less. When you go for the 12th standard, no, it is like a whole big thing is there to study in that. Actually, it's nice to learn so many things about the nature. Magnetic field due to a current carrying conductor. Carry conductor. Magnetic field due to a current carrying conductor. Any current carrying conductor will produce the magnetic field. Okay, any current carrying conductor will produce the magnetic field. Hmm? So, for example, if you take a wire, if you consider a wire, so current will flow in this direction, in the downward direction. Hmm. Any current carrying conductor will produce a magnetic field around it. Okay. So first thing, any current carrying conductor will produce a magnetic field around it. Always like that. Huh? Tomorrow surely I'll reduce this. This one both will reduce. Okay. So any current carrying conductor will produce a magnetic field. Any current carrying conductor will produce the magnetic field. Okay. So we'll observe that if the current is increased, if the current is increased, then magnetic field will be also increased. It is everywhere the same thing. Okay. If the current is increased, then the magnetic field produced around it is also increases. And the other thing, if the direction of the if the direction of the current, if you change that, then direction of the magnetic field lines will change. Again, I repeat, see, a magnetic field due to a current carrying conductor, due to a current carrying conductor, a magnetic field is always produced. Okay. And how it will be? It is directly proportional to the current through the conductor. That means if the current is increased, its magnetic field also increases. If the current is increased, its magnetic field increases. If the current decreases, its magnetic field decreases. Okay. And if the direction of the current, if you change the direction of the current, then the magnetic field direction also will change. If you change the direction of the current, then direction of the magnetic field also will change. Okay. Now, how we will try to see that in a different conductors, that is in a different types of conductors or the in different shapes of the conductors, how the magnetic field produced, how it will be, that is its direction, how it will be there, how it will be, whether it is in the concentric circles or whether they are parallel, the field lines are parallel to each other, that we will try to study here. And to find the direction of the magnetic field, we will use different rules. Right hand thumb rule, Maxwell's rule, so many are there, no? So we will try to study that, okay, in this chapter. So, in a wire, okay, in a straight conductor like this, a magnetic, when current is passed through that, a magnetic field will be produced. They will be in concentric circles. They will be in concentric circles. So, first thing, when current is passed through a straight conductor, okay, straight conductor, the magnetic field produced will be in the concentric circles like this. Okay, it will be in the concentric circles. So we'll write few things about that. So this much understood, no? Write down. In a straight conductor, in a straight conductor, the magnetic field produced when current is passed through it, when current is passed through it, through it, through it, are in concentric circles, Next one. The magnetic field produced is directly proportional. It is directly proportional to the current to the current through the conductor. Current through the conductor. Current through the conductor. That is, B is directly proportional to I. B indicates the magnetic field, I indicates the current. Always we use B for the magnetic field and I for the current. Okay. Next point. The magnetic field is inversely proportional. It is inversely proportional. B means magnetic field. The magnetic field is always indicated by the letter B and current is indicated by I. Okay. So the magnetic field is inversely proportional to the distance R from the current carrying conductor. From the current carrying conductor. Current carrying conductor. Keisha, don't talk. Okay. The magnetic field is inversely proportional to the distance r from the current carrying conductor. That means if you take any distance r from the conductor, if that distance is more, if I take one point P here, okay, so the magnetic field will be less at this point than if I take this point Q. Okay, so from the center of the conductor, if the distance, if you take, it is inversely proportional to the distance. That means if you go to the farther distance, magnetic field is less. If you take the point at the nearer point, nearer to the conductor, it will be more. So as it moves from the conductor, the magnetic field will be less. The magnetic field lines will be less only. So what do we observe? The magnetic field will be inversely proportional to the distance r from the current carrying conductor. That is, B is proportional to 1 by R. Write down B is proportional to I by R. B is proportional to I by R. Next, write down Maxwell's right hand thumb rule. Right hand thumb rule. Huh. No, 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 no. No, they don't ask here. That's what I don't know. In 12th you have, here you don't have. That too, if you take CBS, you will study everything really fully, you will be knowing. But it's difficult. Yeah, scoring it is difficult. But if you take, actually, we'll be detailedly studying in that. Okay. Yeah, it's better to take states. Scoring will be easier. Maxwell's right hand thumb rule. Write down this first. It states that if you hold the carrying current carrying conductor it states that if you hold the current carrying conductor in the right hand of in the grip of your right hand in the grip of your right hand okay in such a way that the thumb indicates the direction of the direction of the current, direction of the current. This is current Cu. Okay, direction of the current. Then the direction of the direction of the curl of the fingers, curl of the fingers will give the direction of the magnetic field, will give the direction of the magnetic field. This is important. Maxwell's right hand thumb rule. Listen here. Maxwell's right hand thumb rule. Written? Still writing? Okay, right. Okay, listen here. This one. See, if the current carrying conductor, if there is thing, this is a current carrying conductor and the direction of the current is downwards. Okay. So we keep the thumb in the direction of the current and the fingers curl around it will give the direction of the magnetic field. Okay. Again, I repeat, see, when it is a straight conductor, current is flowing in the downward direction and you have to keep the thumb in the direction of the current. Then the fingers which curl around it will give the direction of the magnetic field. And the magnetic field will be concentric circles. Around a straight conductor, the magnetic fields will be in the concentric circles. Okay. So if the current flows in this direction, in the upward direction, then the magnetic field will be in this direction. If the current is flowing in the downward direction, the magnetic field will be in this direction. So that's what we had written the first diagram, no? Here. It is in the downward direction, then the current will be in this direction. The current will be in the downward direction, then the magnetic field is in this direction. Magnetic field due to a current through a circular loop. Right on. Magnetic field due to a current through a circular loop. Roll है. Right. The magnetic field lines due to a circular coil as shown in the given figure, right? As shown in the given figure. Right. Drawing here, it's actually difficult. Circular coil. Yes. What? No, what is shown in the given figure? It's shown in the given figure. What is there to laugh? So in a circular coil, if there is a circular coil and current is passed through this, so a magnetic field is produced. So any conductor, if a current is there, through that magnetic field is produced. But what is the pattern of the magnetic field lines? Okay, so we'll try to study. Write down. Write down this at every point on a current carrying conductor, on a current carrying circular loop. Current carrying circular loop. The magnetic field is in the south pole. This is north pole. Yes, only that's it. From that, it should be towards the left. This is like this. Okay. At every point on a current carrying circular loop, the magnetic field is in the form of concentric circles. Is in the form of concentric circles. Okay. Next. At the center, right on, at the center of the loop. At the center of the loop, the field appears to be a straight line. Appears to be a straight line. Then B is directly proportional to the current. That is, the amount of magnetic field produced is directly proportional to current. Okay, still it is there. Tomorrow we'll continue. Just write down. And in this thing, diagrams are important. For everything, you should write the diagrams. Okay. For the questions, they'll ask the magnetic field due to current through a conductor. Next, they'll ask about the solenoid. Next will come solenoid. So, you have for everything, you should draw the diagrams. Okay. Then, like electromagnet, solenoid, all this. Next, it will come. We'll study tomorrow. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.